Well, welcome everybody. Glad you're here. Let's have a great discussion all about radio astronomy. I'm Ted Klein. I'm up on the board, and Rich is not here. So let's see if we can make a great Drake's Lounge. What are we at? We're at July 21 of 2024. I see Wolfgang. Are you there? Oh no, let me first talk about Sarah things. We have a conference coming up. That's available on Sunday through Wednesday, August 4th through 7th. So please sign up, at least online, to be part of all that. Um, we have Dennis. Do you have any other comments, Sarah related?
I do not. Thank you very much. Pleasure to be here.
And do you have any comments for us now about Sarah and its organization?
No. I have been out, as many of you realize, for quite a while, but just starting to get back into frame of mind where I can concentrate and do this stuff, and I'm looking forward. I'm trying to see if I can be of any value to Sarah. That's the only reason to be here. Um, One thing that I have been doing recently, I've been studying some of the history of Green Bank. And one of the things I discovered there, and many of you probably already know about this, was an old device referred to as the calibration horn. It was built, I believe, in 1969 and used for about 20 years, if I recall. But regardless, I'm trying to find out any history on that, and if there are anything is in the works to try to turn it into at least a museum piece. If nothing else, I certainly don't expect it to become operational, but it would be nice to have it as part of the history of Green Bank. So that's one of the projects I'm working on right now. Thank you.
Very good. When I talk, here's a picture of it. It's a great big horn on a slope in Green Bank, West Virginia, and it was pointing towards a standard spot. It didn't move and allowed for calibration every day, apparently. I'll let you study that on your own. Very good. Um, any other thing related to the Sarah organization? Here's a good chance to speak up.
No, not at all. I've
Okay.
been following the emails in all my time gone and trying to keep up as much as possible. Thank you.
Very good. I'm moving around the globe for those who have to finally get to sleep. I think of Wolfgang. Let's start with you. What's news on your world?
Well, there's actually limited news. I've been traveling last week all the time, spending some time with my daughter, traveling around. So was a bit of family matters rather than radio astronomy. As far as our FRB observations is concerned, I believe I mentioned it in the last meeting or so that we see less activity from our present targets. So we have scaled down our observation effort. On the other hand, I have also mentioned that we are working on some subjects in interferometry. We're still working on that, getting more and more into the depth of the interferometry questions and how to deal with it the best. So that's continuing work. The only thing that's really new is, and that's actually an old story, we have again connected our two of our smaller dishes, the 1.2 and the 2.3 meter dish, again to form an interferometry. We haven't done that for quite a while, so we had to set that up again. We did it this morning and just doing the first measurements and first observations with that. also as part of the exercise to learn more about interferometry. And yeah, I guess that's all for the moment that I have. No any exciting news, no new FRB or anything like that.
Thanks for the update. Sounds good. Also far east of me is Dr. Andy Thornett. Andy, what's going on in your world?
So to keep trying to turn the audio back on. Not very much. I've got a knee replacement surgery in a couple of weeks. Unfortunately, I'm in quite a lot of pain at the moment, and it's sort of stopping me from doing anything at all, really. But I'm hoping that it will be magical, and then I'll be back full throttle. But it's great watching everybody else do things.
Very good. Thanks for that news. Dimitri, what can you tell us about Macers?
Hello to all. I am preparing for conference. Today's short message about measures. Just a moment. This is about my my work in data collecting in 2023 about 6.7 gigahertz CFUs A measures and estimates of its variability. For now, new fresh data were published from Japanese IMET, in Japanese IMET database Ibaraki, and I can compare my data with Japanese data about CFUs A measures. This is this is a set of my data published in about 1 year ago in a journal. Spectrums for CFUs A measures can be um, divided into parts: blue shifted parts and red shifted parts. There were 16 points, 2 hours of integration for data collected by me. And this is a picture sample from Ibaraki IMET site, this reference. Data was collected with my old dish, 1.8 meters in diameter. This is characteristics of this telescope. And data collected data are with low signal to noise ratio. So there was some efforts to collect this data and to and post processing of this data. About IMET data, Ibaraki, fresh published data. Here I marked a period of when my data were collected from beginning of June 2023 until beginning of August 2023. This period is marked on Ibaraki plot, but their data is were done for uh, uh, 5 different fishes of Maser. They distinguish it. They distinguish these fishes. Also 16 points in 2 months of this period. Uh, 3 of fishes they distinguish uh, related to blue parts of these masers, and 2 of them can be grouped to red parts. To red part for spectrum I can see from my data. Flux densities in these groups inside these groups are summed together to get uh, resulting intensity in blue part and red part of spectrum. Ibaraki date is Baraki date with very low noise, almost zero, and I even don't take it into account for further processing. What about processing? Processing to estimate variability of these measures. First, variability index. It is calculated by statistical method. This is variability index. It includes statistical deviations of the data taken as peak for density, flux density, uh, statistical mean calculated from data. And because of my data is low noise, low signal to noise data, the background noise parameters, deviations have to be taken into account. And this variability index, the background noise is taken into account in this way. For Ibaraki data, deviation of noise is taken there. And correlation coefficient between 2 parts of spectrum was calculated by these ways. Mean was taken into full set for Ibaraki data and my signal to noise data. Parameter for my this parameter of noise, background noise for my data can be slightly adjusted between 15 and 17 Yansky, as it can be seen that visually about 1/3 of peaks of background noise can be taken this deviation parameter. And results for variability index for my data for 2 parameters, background noise parameter 50 Yansky and 70 Yansky. It is most closer to the Ibaraki variability indexes for 70 Yansky coincides very well for 70 Yansky. For blue parts variability index and for red part variability index, and correlation coefficient for my data, mm, for my data, minus 0.1, and almost the same for Ibaraki. I made data coincidence is for Ibaraki data almost noise less, and my data with significant noise is very well coincides, and I see some difference in levels of received received peaks, obtained peaks in Ibaraki data is somewhat they flux densities is somewhat larger. And I I was surprised about rather low absolute value of correlations coefficients, but Ibaraki data confirm so rather low absolute values about minus 0. About 0.1. If I move median feature minus 3.66 kilometer in second to from blue shift parts to red shift parts, correlation coefficient is about 0.7. I was expected this value, but obviously this feature is have to belong to blue shift parts, not to red shift parts, and movement of different features in this measures. This is map of measures from uh, very long base interferometry in Japan, obtained movement and excitations of different features is more complicated than it seems more complicated than it can be seen from two parts from simple two-part spectrum. What I can see in my small dish with low signal to noise data. Saying this all for now. More details I is included in conference paper, so you can see it. It's okay. Thanks. With some questions, I'm glad to answer.
Wow, thanks for the update there, Dimitri. Any questions for Dimitri at this point? Well, excellent. Thanks for the update. Someone?
Oh, thank you.
Very good. Thank you.
Yeah, I just wanted to say great work, and I'm really getting quite excited
thank you.
about seeing like amateurs actually attempting to do these sort of like major time series projects, which is I think is really challenging and also very exciting. So yeah, excellent work. I was just wondering, like, do you maybe know like why as this particular source is very peculiar double peak spectrum? Because I've also seen that at 22 gigahertz for the same source. So I was wondering, like, is there maybe an explanation for this this typical double peaked signature?
Well, some of it's coming at us and some of it's going away from us.
That's
So just the
obvious, yeah.
Doppler effect.
Oh, Edward, I just missed some words about internet. Thanks for your reference to Ibaraki data 1 year ago. It's very helpful. If some questions I can answer in chat and in other or other means. Thanks.
Very good. I'm walking around the globe. Rob Lucas, it's dark where you are. What time is it out there?
Well, right now it's 23 minutes after 4 o'clock in the morning. And I mean, it's really dark outside.
We appreciate you being here. What's news with you?
Well, what's happened is I've restarted the radio telescope in the backyard. I collected data, haven't done anything with it. And while it's collecting data, I'm trying to figure out what to do for the next radio telescope. What I've done is, I've obtained a kit for Alex's Yagi antenna, and I've collected things to make a tracking radio telescope antenna, and working on getting that done. Working with the metal worker to create the pieces to make it work, and also to get the electronics that will drive it. And trying to figure out what to do for the next, experiments with radio astronomy. I also have a second, scope in a box, and hopefully try to play with, some of the interferometry for that, as well as what to do with the third and fourth radio telescopes. So basically nothing new to report except, work in progress. Okay, and trying to wake up. Thank
Always
you.
a list of things to be working on.
Always. And that's just in the radio astronomy, not in the optical. The optical has a whole bunch of other stuff too.
Some of this explains why you're up at 4 in the morning. So good for you. Thank you, Rob.
Okay.
Edward, remind me where you're located, please.
I'm located in the Netherlands, so in the same time zone as Wolfgang. Actually, OccultWatcher is not too far away from where I live, so I sometimes visit.
Well,
Yeah,
we thank you for being here. What's news with you? What's going on?
not much actually. I have no new things to report since the last meeting 2 weeks ago. I've just been gradually working on the mount project, which is going really slow. But now I just like hooked up the electronics in the mount, and I've started to do some like actual testing with it. And yeah, I'm still running into a bunch of problems with the stepper motor stalling or suddenly like turning at very low speed while doing slewing. So yeah, there's still a lot of issues to be worked out with the on-step configuration and everything. So yeah, I guess it's gonna take like another, I don't know how many months or years, but I hope I'll get there eventually. I have also done some observations with the radio telescope, but not so much because I've mostly been doing optical astronomy because finally we had some good weather here. I have attempted to detect 2 different sources at 22 gigahertz without success. I'm currently like, I've been going through the list of the brightest water masers for the past 2 or 3 years, and I've detected so far about 9 of them. But in the past year, I haven't detected any new sources actually beyond what I've already observed before. So it seems that I've actually reached the limit of what I can do with my 1 meter dish setup. But that's okay. I mean, like these sources are very variable, so it's also interesting to just observe the same sources over and over again and see what changes. So that's also an interesting direction. Yeah, so not really much news from my side. I have no new observations to show really. Any questions?
Very good. We're all working on lists without uh, in the with results still to come, I guess.
Yeah,
Good. Thank you.
another amateur told me that like every hobby just eventually devolves into some form of got to collect all of the items.
Excellent. And then there comes the data collection, which takes time too. So all
Mm.
makes sense. Alex, are you available to tell us what's new in your world?
I am. Good afternoon. Couple things. About 2 or 3 weeks ago, I put up on the Sarah site a 50-page presentation which documents the past 6 months of the 21 centimeter Yagi project. And then in addition to that, because I'm not sure how many people are familiar with the analytical portion, I have created a subset of that. The Yagi documentation is broken into segments where it's an overview. I give some information on the analysis, the testing of it, the results, and some details on construction. So if anyone wants to build one on their own, there is great detail on the fabrication of the components and their spacing. But as I said, I pulled out the modeling and augmented that slide set. I think that's about 35 slides or so up on Sarah. I have a subset of that. I have about 15, 16 slides that I would like to overview and give you an idea of what antenna modeling is and what its value is. So with that introduction, see if we can do this.
Alex, I was impressed with all your work. I thank you for posting all that stuff.
Thanks.
Keep it up.
Is the
I see a full screen. Looking good.
Okay, all right. Okay, so here we go. This is focused on the 21 centimeter Yagi, but it's a general concept of antenna analysis using a NEC code, numerical electromagnetics code. And the code was developed in the 1970s by Lawrence Livermore Lab. And what you do is you divide a complex model, a simple or complex model. It could be a single wire dipole at 80 meters, up to more complex structures like I have, and you model it in a set of wires and surfaces. And so the general concept is you create a wire list. Some of this can be automated. Generally, a lot of this has to be manually adjusted. And you create a wire list. Each of the wires is tagged. There's a XYZ starting point, ending point, and the radius of those of each of those elements. And so when it's displayed, it looks like this. You see a series. Each one of these is a wire. And in addition to that, in order for it to be modeled, these wires are broken down into fractional wavelength segments. And so in this model, they are 20th wavelength segments. And so the model gets complex. And for the analysis, for the computations, each one of these, a red, green is a segment. Each one of these is calculated. The current of each of the electric properties, the electric current and the electromagnetic fields, the E and H fields for each one of these is put together, and you create this pattern. Now, by itself, an analytical model is just an interesting academic exercise. Without some way of proving it, it's just a pretty picture. The other half of this is model validation. And that's the other interesting part, in that if you can validate the model by doing tests that confirm the model is correct, then it becomes a useful tool for performance prediction, and you can predict, hopefully reliably, changes in modifications. And so that's what I did. And these are just a few snips of the overview of what was done. I rotated the antenna through azimuth and measured its reception level, RF intensity level, and calculated the beam widths of two. This is the 3/4 and 1.5 meter long Yagi. These are measured values versus the NEC models. So I've got 23 versus 24 half power beam widths for the long one, and 29 and 32 for the short one. So that shows that the model is well correlated to tests. Another is looking at the total maximum gain of the 1.5 and 0.75 meter Yagis. Looking at the difference in levels shows a high correlation there. So each one of these little pieces shows the model is well representative of the actual physical hardware. Another one, there is a transition that I hadn't spoken before, I don't believe, in that I've moved from the disc Yagi to a plate Yagi. The circular segments are tough to make. I've been cutting these on a lathe. There's multiple steps involved. They're tedious. I came up with a thought of seeing if we could make rectangular elements, and it works well. This is the model that shows theoretically the discs and the plates should perform identically. And if you forget this end out here due to the SDR temperature drift, they do. The rectangular elements can replace the discs without any degradation in performance. So that's another step that says the model's good. So overall, this is the description from the field test, and this is what the model looks like. So I feel that I had a very good model with which to test various changes in parameters, such as I went through a study of spacing. The element spacing from 30, 40, 50, 60, 70, actually did an 80 millimeter element spacing and found the best one. And of these, looking at these, the 60 millimeter spacing was chosen. This is just a comparison between 40 and 60. It shows the 60 is the preferred. And so this is another test versus the model that shows the model is robust, is valid. And so this was what's chosen, and this is what's has been constructed, is a rectangular element directors with 60 millimeter spacing. Here's another interesting study. This is just a small, the driven patch reflector and one director set. And I ran a VNA analysis of this showing that this thing is tuned to, I think it's 1440, and showing the response here. And then I modeled that, and the results are identical. I mean, the model is coming up very nice. So this is another confirmation that the models match the reality. And so that's just an example of what I've been getting with the system. And that's the end of this. Also, I have put together several kits that I have to drill a few more holes, but they're available. So if anyone wants a kit of parts, you've got to supply the stainless steel rod, because it would probably cost me 3 times the $6 price at Amazon. So you buy the rod. The rest of this, I'm selling these for $50 plus shipping. Shipping in the States is between 15 to 20. Cost about $50 to Australia. So $50 US mail priority express, and it took 2 weeks. But if you're interested, this is a good set. These parts are cut to within plus or minus a millimeter. But all of this these dimensions are available on that document that I posted a couple weeks ago. That's the story. Any questions?
Yeah, I have one. How did you do your field test?
I'll tell you what. Let me let somebody else give a presentation, Preston, and let me go back and find the slide set. That is part of the large document. Let me bring that up. I'll show you 3 or 4 slides of how I ran the field tests.
Okay.
There's one other thing I do want to show you, and that is the actual NEC analysis software. Let me stop that. Let me see if I can. Hold on. Let me see if I can share another screen. It's not coming up. Oh, wait a minute. Maybe it will be. Let's try this again. I don't know. Let's see what this does. You're seeing the whole screen, aren't you?
I see a full screen
Yeah,
with
you
a
see a full
background.
screen.
But over on the
All right.
left, I see something moving around.
Yeah, well, let me.
Can you max that window?
Let me, yeah, let's try to do that. Let's try to do it that way.
That looks pretty good, except I'm seeing
Yeah,
the top part of the picture.
except, let's see something here. So this is the structure, and this is one of the 3D displays. And although the engine for this may have been written in the early 70s, this is some nice free software. It moves, it's dynamic. And so these are the elements, and then you can overlay this structure with the radiation pattern. And so the software is fun to play with. In addition to this, I mean, there's lots of other things that can be displayed. You can look at the currents on each element. Let's see, there you go. And so it gets a little busy down here, but on the directors, you can see there's the typical shape for about a half wavelength element. That's all I wanted to show. Okay. Are you back on? Yeah, we're back.
We're seeing all the gallery.
You're back.
Excellent. Thank you for all that overview. I got a bunch of questions already to start off with. First off, you refer to the 50-page, and that's up on the listserv, which is actually available to the public. We'll put a post in the...
Right, I put it together as a PDF, so it goes down from about 30 megabytes to 5 or 6. So it's a PDF document.
Much better. Good. You're talking all about the NEC software for antenna modeling. You can get a free version of that, and it has some limitations, but you have lots of elements.
Has no
limitations anymore.
It has no limitations. That was written by Ari Voss, VOOS, someplace in Europe. It's been around. He's had that up there for at least 10 years. He's been developing this. It's always been free. There are others out there that write their own, store their own code in proprietary format. This 4NEC2 is free. It's written in ASCII format, and you need that because a lot of times you need to bring in the ASCII files and append these together. You create like maybe the feed and the director, and then you need to tie in the base, the directors and the main tube, the spacers between them. So you need to have the main file stored in a readable file that you can use other tools to cut and paste the structure together. For NEC,
that's good news.
For NEC2, yeah. And it comes with...
Is there a link that is not in your PDF? Should we post that? Or is it just Google?
I don't know. I'll find it for you and stick it in the...
You have some little black parts, which are spacers. I'd be interested in where you got those. Do you have a link for getting those? Well, you have spacers between some of your large circular elements, aren't they?
There's a half-inch diameter thick wall aluminum spacer between every part, and I cut them. I bought 6-foot segments and a mini chop saw, aligned it, got it precise. There are 100% right angles. I chop them up.
Let me use a different word. We have little insulators.
No insulators.
The little black.
The little nylon standoffs. Look
Right.
for
And where do I
Amazon.
find things like that? That's
Amazon. 10 millimeter long, 3 millimeter threads, and you can find nylon nuts. All that other stuff is Amazon.
Okay, so we don't need a secret link that you found.
No, and in one of the pages on the main document, the construction documents shows what's on the kit and labels everything. So you can
Excellent.
go there and find all the little pieces.
There was so much to consume there. Very good. And then you were just now you were using some 3D visualization software.
That is for NEC. That is the free
it's
software.
inside it. Wow. Okay, great.
Oh yeah, it's very impressive. I mean, it is. I have used this for over 20 years. I did this for development of some very interesting 10, 20, 40 millimeter amateur radio antennas that were more wires and inductors, loads, capacitance hats, all kinds of crazy stuff. And in that environment, because it is not isolated from Earth, you need to put in conductive surfaces like Earth. I have a folded vertical 20-meter dipole in the backyard. I constructed the aluminum struts of my backyard patio pool and to see how that influenced the beam. I mean, you can consume many hours. I'm sure over the past 20 years I have created 1,000 models. Maybe small changes, but it's quite immersive, and the ability to display the answers is pretty impressive. And then when you build something and it matches a model, it's really rewarding that it's not just this arbitrary mathematical something that comes out of a textbook. It's real.
Very good. And I see Monroe has posted the link for it now. I just got to get up to date. I think I've been using something else. Excellent. Thank you, Alex. Questions
You're
for
welcome.
Alex?
You're welcome, gentlemen.
Very good. Okay. Is Detlef still here? He may have dropped off already. I apologize. Okay, good. We'll see if he returns. Coming down my list, Charles, you're at the top of my list. What's news in your world?
Not too much. Been busy on indoor projects. It's been 90 plus degrees outside for like 6 weeks. Rough weather around here. We're finally starting to get some thunderstorms now, so that's not good for working outside either. But I am doing some observing at negative 37 degree declination anyway, because that seems to work good. Let's see, I had comments for Dennis on the calibration horn. Let's see, yeah, Dennis is still there. Yeah, I had, I think Bruce had made a hike down there, Bruce Randall, on one of the Sarah conferences in the last 5 years or 6 years. And he said he was surprised it actually had power to it. The horn is very grown up, and of course the woodwork is somewhat deteriorating. But the building still had a power meter that was hooked up and running. And I think somebody has talked to Sue Ann about potentially getting access to it if we wanted to go down there sometime and try to actually hook up a RTL SDR or something, during one of the conferences. But it's subject to a lot of issues. I'll tell you that Jim Carroll and Jim Sky used it back in the 90s during one of the conferences. We all did kind of a hike down to that. And the problem typically is if anybody forgets to take the waveguide transition off of the horn, you can imagine the amount of water that thing will collect. So the waveguide transition always has to be removed um, and left off so that the rainwater that comes down it ends up coming out of the open end of the horn and inside that little building and goes into this giant trough that's under the end of the horn so that it can drain out. So if anybody forgot and left that transition on there, you can imagine all the crud that would get built up inside that and the water and stuff. So sometimes it would take quite a cleanup to actually put it back in operation. So I think Sue Ann was, she said there might be a way to do that, and Bruce sort of made the comment that it was pretty snaky and subject to wasp and stuff down there, so it could be a kind of a tricky place to be if you're like me and you're allergic to bee stings, things like that. Let's see. So let's see. Any other questions on that one, Dennis?
No, thank you very much. I may be getting email to you or checking with you. I'm just gathering all the information I have. It just seems like it's a piece of history that would be nice if it could be preserved and at least have a plaque put on it or something, so people know more about it.
Yeah, it doesn't look too much like Ted's picture right now. It's very grown up, with small trees and stuff all around it. And I think the wood structure may have even shifted a little bit, so it may not be pointed at the calibration target quite as closely as it used to be.
Do you have any information on the coordinates it was pointed at, or do you know where I might find those?
I thought it was a Cass A horn. Does that make sense based on what it looks like?
Well, yeah, but Cass A it's not stable at a single point in the sky, is it?
That's why they were doing it. I think they were actually using it to measure the drift in the source amplitude.
Okay, yeah, well, that's the center of the Milky Way, I guess, isn't it?
No, not Cass A.
Oh, I'm sorry, I got that backwards. Okay, well, I will continue to look into it. Thank you.
Yeah, it's looking up towards the north, if I remember right. So, but anyway, Bruce, maybe even Tom Crowley might remember some about it. But there has been some effort recently within the last 5 years to, discuss could we use it kind of thing. So yeah, that's all I know at the moment. So Bruce Randall, NT4RT, would be a good one to see if he remembers some more details than I do.
I'd be interested in what kind of results came out of it and what kind of papers or realizations. Excellent. Someone else was speaking as well.
I'm sorry, it was Dennis. What was the name of the person you just mentioned that might know more about?
Bruce Randall, NT4RT.
Okay, yeah, I know. Of course, I know Bruce. Yes, thank you.
Very good. Thank you for that. On any other subjects, Charles? Very good. Okay. I have a list here, and Jameson is on there. Jameson, what's new with you?
Hey, what's going on? Not much in the way of observations, but I am working with Alex. What we'd like to do is have a program that can slurp in the IF average files, do the processing and so on, and create a .csv. It'd be very easy then to pull into some software. Alex found something called Renier. I'm not even sure how to pronounce it, but it's basically allows you to do really neat, pretty 3D surface graphs of data. So that's what I'm working on right now. I've been looking at some of his MATLAB code. And I'm trying to do the same thing in Java. so it can run anywhere, everywhere, and people don't have to shell out $150 for something like MATLAB. But it'd be a way that people could quickly, take the data from their telescope, graph it, see, how it looks, and hopefully be a tool where people can figure out like what their shortcomings might be and how they can improve their setups. So first version is still very much in progress, but I will let everyone know when we have something that's ready for people to be guinea pigs for. So if you have any questions, let me know.
Excellent. Thanks for that news. Jason is next on my list. What's going on with Jason?
Yeah, so not a lot of not I don't really have any observation news, but I have what I've been working on the last few days is actually yesterday or no, I think it was Friday. I ran through a kind of a dry run of my presentation for the conference. And my oldest two children graciously sat in on that and gave me some feedback. And basically, it was just to kind of do an initial test run on it to see how long it was taking. I'm kind of trying to follow Jay's advice and keep it around 15 to 17 minutes so that there's time for Q&A afterwards. And yeah, so I was doing that. I also had to do some mechanical repair to my dish. The dowels that are kind of the central core of the sliding central portion that the ring slides on to fold the dish, and also becomes what holds the feed in place. Those dowels had actually come loose from the base plate. They were glued in. And so I ended up drilling the holes all the way through the base plate and basically inserting the dowels through the back end and putting a bolt or a machine screw in as kind of a pin to hold it. And then on the other side, there's some PVC pieces that slide over it that create the shelf that the ring sits on when the dish is fully open. And so those were then held in place with nylon screws to keep it tight. And that way I'm not dependent on glue to keep those things in place. And so that seemed to work well. I got it kind of opened up, and I actually attempted to do a scan of M101 last night, but somehow my software crapped out on me, and I don't have any data files, so I'm not sure exactly what happened there. But I also did notice today when I was looking at my elevation settings that I had actually made a math error in my elevation setting calculations going all the way back to the beginning of my observations. I was mistakenly using a sine function instead of a tangent function. And it was based on the geometry of how I was elevating that base plate. Anyway, for most of them, the error for M31 and M33, the error was 0 because it was so close to zenith, it didn't make any difference. But some of as it gets lower in local elevation setting, the error gets worse. And so some of my sources were the setting was as much as 3.5 to 4 degrees off. So that's something in the future I'm planning to repeat those observations and see if my results improve at all. Yeah, so my goal for the next week or so is to polish my presentation for the conference, and I'm really looking forward to going out there. My girlfriend and I decided that we're going to leave a day earlier than originally planned because I'm going to take a little side track out to Philadelphia area and visit USA Kilts, where I buy my kilts from. I've been wanting to visit those guys for a while, so I was like, I'm going to kick myself if I got within 3 hours of that place and didn't go. So anyway, that's going to be kind of a sidetrack as well. But that's all I got.
Thanks for the update. Very good. On my list, it says Mike Caba. Tell us the news.
Of course, I'm very much of a newbie in this, and I do have two news items. I think it was a couple weeks ago I mentioned in the meeting that was hosted by Rich Russell, I think, that I'd completed the itty bitty radio telescope, and Sky and Telescope is actually going to do an article on my experience in building and using that. I've seen the rough draft of the article. It looks pretty good. And Tom Crowley, I believe, is in there, and Sarah is mentioned, so that's kind of cool. So that'll be coming out after the first of the year. And then, so as a newbie, I'm kind of working through some of the introductory projects that people often do. And one of the things that I'm working on is meteor detection. And I'm wondering if, and people have been extremely helpful on the Google thread with questions that I've had. And one of the things that I'm wondering about is software suggestions that would allow me to record both audio and visual off of my screen, my computer screen. So just record so I can come back later and see what has taken place, but just to record that, the spectrum and waterfall and the pings and all of that. If there's any suggestions, if you could send them to me in the chat, I would appreciate that. And that's all I have at this point.
If my memory serves, it was Spectrum Lab that was the convenient recorder of that. And there are ways for certain time periods to take snapshots every so often. We were a little surprised when we loaded somebody's configuration, and we found it was filling up the disk because it was taking pictures in the morning at like 2 a.m., which is a good enough time, but we didn't know it was doing that.
Yeah, let's see, the SDR Sharp, I believe it is the name of the program that you can record on there, but and record your screen and both the visual and audio. But boy, it takes up huge amount of disk space.
Well, that's more like an electronic output. No, I'm talking about just pictures. This was taking screenshots, and so I think we got to get you some info on that.
Yeah, if you could send it to me in the chat, or can maybe put it out in the Google group or whatever. But I would really like to see if there's just a software that will record my screen, both video and audio, for later review. So that's all.
There are other folks that know much more about it than I do. Very good.
I would say take a look at the occultation community, where you're monitoring something obscuring something else, because they typically will record imagery plus audio in the background, because to coordinate the observing captures with time, they'll actually overlay WWV as an audio stream with the graphical, with the picture of the camera display. So look in the occultation community, see what tools they're using.
What when you say the occultation community, where would I find them?
If you just Google like moon occultation or star occultation, you'll probably find the community.
Okay. All righty. Thank you.
I mean, Mike, we've had a bit of email correspondence.
Yeah, Andrew, I see, and I thank you for that. Yes.
As Ted says, the standard program is Spectrum Lab. I've got that working, picking up meteors at my station very successfully. So, as I suggested before, you've got my email address. If you drop me an email, we can organize a time and we can do a Teams meeting or a Zoom meeting together, and I can show you exactly how to do it. And you can also have a copy of my conditional files, conditional actions file, which is the one that dictates when and how it actually records the meteors, and I can show
Okay.
you it and show you what sort of it looks like, etc.
Okay.
I don't.
Yeah.
I don't routine play audio, but I believe actually it does record audio. I can say to definitely it does as well, yeah. Because it's a question of having somebody who's doing it to show you, and I can definitely do that for you in the same way as Ted did it for me with his Easy Radio Astronomy. So I'm very happy to do it for you.
All right, great. We're all paying it forward.
But
Thank you, Andrew, and thank you
Yeah.
for your comments. Thank you for your comments in the Google group.
But as I said to you in also in the emails we had back and forth, the one
Yeah.
thing I don't know is what station we use for meteor collection where you're based. I mean, I do know in the UK what we use, but
Yeah, I've got a station that I think out of Las Vegas that will work pretty well.
yeah, so you need an aerial that will actually be able to pick that up, but maybe
Yeah, and I'm working on that. And so I'm closing the gap. There's a lot to learn. It's a steep learning curve, particularly with the vocabulary. But people have been really helpful, and so if we could close that gap in terms of just some of the software can get over that hump. So yeah.
Just remember, whatever aerial you're getting, you don't want anything that's too precise. I mean, you want it to pick up the frequency, but you don't want anything that's too directional. Ideally, it needs to do like 120 degrees because meteors come from all over the place, and if you have it aimed just straight ahead at one point, you will miss most of them.
Okay, good. Very good. Thank you, Andrew, and thank you for your comments on the email. It's been most helpful.
Yeah, so give me a shout and I'll sort you out.
Yeah. Okay. It might be a week or two. I'm not sure exactly time frame here, but yeah, I got your stuff. So thank you.
Yeah, no problems.
That sounds positive. Good. And there are some other postings in the chat for you there, Mike, too.
Yes, I see that. Okay.
Let's do Preston first, and then Alex, if you're still around, we want you to give us an update also with more info. Preston.
So sorry. Before Preston goes ahead, Ted, from Alex's talk, Alex Pettit earlier on, I put a message in the chat, but there's nobody responds. So what's the best way of contacting Alex to request one of his antennae?
I'll let him answer that, and otherwise I was going to send you an email letter with that email address.
Okay, thank you.
This is a public recording. I'm trying to keep that off it.
Okay.
I advertised Preston first.
All right. I'm doing mostly reading and studying still like I was last time. So I'm enjoying what everybody's saying. And thank you.
Very good. Alex, I have a question from what you've already told us. You went from round disk elements, small ones, to rectangular. Now, why not square? And then please tell us about your RF field, your testing field.
You probably could do square. It just adds material and weight. There's no value to it. I mean, you could. I wanted to try to cut it down and to see if square would not have a gain in weight. It's not really an issue with the 3/4. With the 1.5 meter, when you start to get up beyond that, droop is a big issue. Structural integrity of the spine is significant, and so that's why. And also on the construction details, I see no reason why the 3 circular segments for the patch reflector and first director couldn't be hexagonal or octagonal. Square, maybe, but I'm sure you could probably make these, cut these on a bandsaw or something and not worry about having to cut them on a lathe and not degrade the performance. If you change it too much, then you got to go back and test it. But that was the reason that I went to the rectangular.
Very good. And you had a RF testing field. Have you found your slides?
Yes, I have. Let's see. Okay, so this is the backyard, but prior to this, I took this setup into one of the nearby parks that would, had several soccer fields of open space, and did an initial measurement there because I was concerned. The backyard it's small, but it opens into this conservation area, and it's heavy Florida vegetation. Comparing the two, again, I found no issue, and so I continued this in the backyard. So if you look at the top, there's about 35 feet. If you see that in the left side, there's that little trapezoidal shape. That is the a wideband Yagi, and that was for the transmission. And then the test antennas were on this equatorial mount that rolls into an alt-as, so I could rotate this. Let's see. Hold on. There we go. So I can rotate this by using one of the manual verniers and clock off 2.5 degree increments. And so that's what I did. The electronics was a little novel. I just dreamed this up one night and it really worked. Is using one of the standard nano VNAs, driving the S1 output, driving this wideband Yagi. The receiving antenna, I added a couple pieces here. One for the test in the park, I didn't know if there were going to be any cell phones around or what RFI emissions there might be. So I added in this little mini circuit ceramic filter. This is a sweet little filter. It's about $70. So that eliminated potentially any kind of outside interference. I knew I was going to have low gain, and so I added this 20 dB amplifier to it, LNA, and then a DC block because this was being fed by 5 volts. And this worked very well. It's probably all. And then so I went out there, measured every 2.5 degrees, and got some very nice detailed plots. I think that's all. Yep, then can plot it different ways, but that's all from actual field tests.
Thank you.
Okay. Let me see something. Let me see if I can share one more. Yes, here's a teaser. This is associated with Jameson's presentation. This will give you an idea of what we'll be able to do with the IF average data. Some pretty impressive graphics. So stay tuned.
Hey, snazzy, I like it. Thank you for that. I have Preston and then Skip. Preston first. What's news in radio astronomy?
He already went by me.
Oh, I'm sorry. No more news in those minutes? Okay, sorry. Skip, tell us what's going on. You're up in Vermont, looks like.
New Hampshire, yeah.
Oh, pardon me, New Hampshire.
Yeah, I've just been using my interferometer and testing software, rewriting software. Sometimes I find that rewriting the software is the best way to test it. See if I get the same results. And just preparing for the SARA conference.
Lots of preparation going on. This is good. Look forward to that.
Yeah, thank you.
Monroe, you were here a little. Yeah, there you are. Are you near your computer?
Yes, I am. And hopefully, let me privacy filter there. There we go. So 2 topics. We're always talking about antennas and making them bigger and bigger. And I was doing a presentation last night on 3D printing at the nanoscale. And I came across an article in Nature Communications where they 3D printed a Yagi 400 nanometers across. And typically for a transmitting Yagi, you would feed it modulated electrons and out would come radio waves. Well, if you shrink it down to 400 nanometers, what you get is you feed it electrons and you get out blue light. Let me see if I can share this here. Screen 2. Okay, So this is a Yagi. It is from end to end about 400 nanometers. It has 3 elements. The little round dot inside the dotted square is a single gold atom. So they feed electrons in from the left, a voltage, and out comes blue light. So when you talk about spacing and being able to receive at different wavelengths, that applies all the way down to shrinking it where it's sub-radio into light towards the blue end of light. And why this is important is they're always looking for quantum computers and how to move the data in and out from the quantum to more easily usable realms. And if you can take RF at the normal feeds in quantum computers, and you can have that come out as light, you now have the ability to get rid of all of the plumbing associated with the microwave RF of a quantum computer, which shrinks it down considerably, makes the elements less brittle because you're no longer freezing all of the metallic piping for the RF. So I just thought that was fascinating. I think I've got the article. Let me post that. Yep, that's the wrong one. Let me go back and get it here.
Yes,
That's
please.
impressive.
Put that in the chat if you can. And Alex, yeah,
I'm-
he had
I'm in
rectangular. He had rectangular directors in there too. Yeah.
Yeah, look at that.
Yeah, they're only a few atoms across. There we go. Electrically driven Yagi-Uda. Nanoscale. That's from Nature Communications from nature.com. Found that fascinating. And the other topic was T Corona Borealis. I'm tied into a number of feeds for observing it the moment that it starts to brighten. And so I'm using the NASA GCN to pick up on neutrinos from Ice Cube down in the Antarctic, plus a lot of other high energy stuff, and was looking for, okay, will we be able to detect this in radio? And it turns out, yep, it looks like it's detectable in radio, but unfortunately, it's in the high single digit to medium double digit gigahertz. So most of our lower end stuff would need a down converter in order to be able to receive it. But so that's what I've got this week or this time.
Well, you say gigahertz, and so should we put our hydrogen antennas towards this soon-to-be nova?
Well, we don't know exactly when it's going to
Well, I know
nova.
that, yeah.
That's just welcome to reality. But the particular range, remember that it's drawing hydrogen and helium off of the red supergiant to create an accretion sphere on the outside of the white dwarf. And so when it detonates, it's going to be a fusion detonation predominantly of hydrogen, and that would fall into the hydrogen alpha sort of wavelength. So it should be something that is receivable within the hydrogen line.
Yeah, I just wanted to comment on this a bit because I've also been like reading up a little bit on the literature on radio emissions from novae. I'm not really expecting any hydrogen line emissions because like in these sort of like extreme environments, such as in a nova explosion, the hydrogen will most likely be ionized. So you wouldn't really expect to see like the hydrogen line from ionized hydrogen because, well, hydrogen line is forming from it's originating from neutral hydrogen, if I remember correctly. And the other thing is that if you look into the actual brightness at the radio wavelength of these novas, that yes, it's true that there have been some reports of radio emissions at it's sort of like tens of gigahertz or several gigahertz, but all reports I could find were also mentioning flux densities of 1 Jansky or lower for these novas. So it seems rather weak. would be very tough to detect.
Yeah, I think you're right in that the detection you would want for the hydrogen line is actually a decline. So if the shell on the outside of the white dwarf is radiating at the hydrogen line because it's ionizing hydrogen, what you would look for is a sharp dip as the fusion occurs.
Well, there's going to be such broadband black body radiation from that you're not going to see anything distinctive at 1420 or 1520 or 1320.
Okay.
I mean, it's just going to be hot.
Okay. I know that there are a lot of communities that are going to be observing it in different instruments with different ground-based as well as space-based observations, because we now have digital technology that allow us to do this, and this is the first time this has occurred kind of in our digital age. So there's a lot of observers that are turning to, regardless of what spectra they normally work in, just to see the delta.
I'm
Just a
wondering.
quick comment on the hydrogen line. We always have to keep in mind that the hydrogen line is a forbidden transition, and that means it takes a hell of a lot of material to actually detect it. And the reason why we see it is with our telescopes is because we are looking into very large areas. Just the mass of a star, even if it's a big star, if it were all hydrogen, it would just be a mere nothing compared to what we typically see with our telescopes.
Good point.
Yeah, I know in optical observing, we watch the sun at hydrogen alpha, not the hydrogen line. It's obviously not radio, it's optical.
Yeah, that's a completely different story. It's a normal transition, not a forbidden transition, and that occurs in hotter regions easily. But the hydrogen line, as we observe in the radio field, that's simply a different story.
Okay.
Yeah, I'm wondering if there may be secondary emissions if it's in a binary system where you have the dwarf at the core of the nova, right? Then is it possible that there's like a shell of gas out from the system itself from when that previous star shed its outer layers, and therefore you think that it might cause secondary emissions from absorption of the initial radiation from the nova and then re-emission as secondary emissions, like
Yeah, I think that the last time this went off was in the 1940s, and physics and science in general and digital technology has advanced so far that that's the reason why so many different observatories and different technologies are trying to observe this. Is we have some computer simulations and some mathematical models, but we just don't have enough empirical evidence of the onset of a nova in our galaxy. So yeah, there's a lot of questions as to what actually will take place, what will be observable using what kinds of instruments. So that's why there's a lot of interest in it.
Fun topic. Here's our chance. Otherwise, we have to wait
80 more years.
80 years. Yeah. All right. At least for this one. Very good. I have Stanley, Tom, and Don at least. Oh, and Wendy, of course. Stanley, are you there? I don't see you on my list. We're moving on to Tom. What's the news from Tom?
Do you mean me? Sometimes there's other Toms around.
Oh, no, we're talking about you, Tom. Yes, please. BFQ.
Okay, well, what I have to say is I was going to talk about the upcoming Eastern Conference. When last I looked, there were 41 people to be present at the conference for in-person attendees, and the grand total of in-person and online, when last I looked, was 63 people. So that's happening. I do know that there's some money has come in the last couple of days that I need to process. So I don't know what they are, whether they were conferences or whether they were equipment. We're seeing a lot of Super Sid stuff happening. So it's been a very interesting how many of those have happened in the last year. But other than that, the other thing I need to say is that the physical year has ended, so we're starting a new physical year. I'm trying to get the old year closed out so that we can do that. And sometime probably shortly after the Eastern Conference, I will be sending out emails to people who need to renew. I am still seeing a lot of trickle of people renewing their membership, but most everybody's membership would have expired in June, and so we are into a new year here. So that's all I have to say from the treasurer. I'll take questions if people have questions.
Thanks for the update, Tom, and I appreciate all the work you're doing. This is great.
Okay,
Don,
well,
go ahead.
Well, okay, like I say, that's really all I had to say, and I'll see people here in a little while, or whatever comes next. I guess Wendy's next.
Well, I'm going to put Don in here first since I advertised. Then comes Wendy. Don, tell us about that antenna behind you. What's going on?
Oh, that's my 16-foot dish. It's moribund at the minute because I have to get the motor drives going again, and I'm working on it. Cas A is a synchrotron radiator and is gradually running down, but you can go on the web and find papers to use Cas A as a source for calibration, and its characteristics are known as the frequency and amplitude, and it makes a very nice calibration source at this point. Crab and Taurus are also in that category, I believe, and so they're active emitters of radiation at the frequencies that we're interested in, but they are not hydrogen emitters. So they can be used as calibration points. So you can look it up on the web. I'm sure that it'd be very, very fast to find. If you just put in Cassiopeia A and calibration, you'll get 2 or 3 papers. I don't think there's anything really very new about it, but about the papers, but they are there. That's it.
Very good, Don. Thanks for the update. Some of us know Wendy as Captain Ann Flint. Pirate Captain, are you there, Wendy?
What should I say? Should I say, arr?
Arr, yeah,
Arr.
What's your news?
We are thinking of moving at the end of summer, because I was going to move in the summer, but then I decided that was not such a good idea since it was, up until today, it's been too blasted hot. And I'm looking to move to a site where we can stretch out, and build a tiny observatory. But I would rather not discuss this on the, so that it's recorded on YouTube. So
that's fine, and so you're still working on your radio astronomy projects and distracted.
Yeah, but it's mainly like doing reading and doing research. I got real intrigued with Tom's question of looking up the audio from the Jupiter crash that was on the
On the listserv. Okay.
on the listserv last week. So mainly I've been doing just research and reading and trying to get everything cleaned up so that when we move, I won't have to go through old magazines and stuff like that.
Well, that would be a new approach for some of us, actually doing the reading first. So well done.
Well, wish me luck. And if I want to discuss radio sites somehow, if I can just do it in secret, because I'm hiding out from people I would rather not know that I'm moving and where we're moving to and blah, 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 stuff like.
Well, that's what pirates do. So we wish you luck on all your travels there. Good luck with your projects.
Okay,
Thank you, Wendy. Rick, K0GD, are you there? Marvelous picture. There you are.
Here.
Oh, even better picture now.
Well, that dish has been fully recovered now and delivered to our site at the Deep Space Exploration Society in Haswell. I've got hundreds of pictures of having it disassembled and having it delivered and unloaded. But we've already published some trip reports that most people have seen already. So I won't go through that again, but I'm going back to this site in Thursday because there are more antennas on that site and towers, and I decided to buy one of the towers for myself. It's the tower with the little, let's see, the elements that are up in the corner. There's an 80-foot self-supporting crank up tower there, and I decided to buy that. So I'm going back 6-hour drive each way, towing a big trailer, but we're going to load that other tower on the trailer, and I'm going to put it up here. I have no idea just what I'm going to put on top of it, but I'll get the tower first. Oh, that's it.
Excellent. Thanks for the news there. Now we have a new toy to play with out there in southeastern Colorado.
Well, we could use help reassembling it, I'll tell you.
Well, that's right. There's a lot to play with there. Big, heavy things too. Lots of cement work coming too.
And we need some additional donations. And donations that have been received were very helpful in covering our costs of retrieving it so that it didn't go to the scrap dealer. But now we need concrete and physical help to put it back together. I think we're going to start assembling it as soon as the weather cools off. We have an open house in October. Maybe we'll start assembling it then. We'll have volunteers on site.
That'd be good. Put them to work. Exactly. This is a group in southeastern Colorado, remarkably big 60-foot dish. There's a link in the chat. Now, of course, this is supposed to be the Drake's Lounge where we ask questions, but I went around first just to find out what the news was. Does someone have a pressing issue that they need answers for? Here's the chance. Everyone has their answers. This is good state of affairs. What else should we talk about? Do you have another subject? Otherwise, thank you. I hear quiet. So thank you all for coming today. About an hour and a half. That worked pretty well. Unless there's another subject, we'll see you. I guess the next one is Friday coming up. In my world, anyway. Drake's Australia. To me in Colorado, it will be Friday evening about 5 o'clock. Join us there too. Look for the link in the listserv. Get the
Good
news.
afternoon, everyone.
Thanks very much.
Take it
Goodbye.
easy.
Thank you, everybody.
Bye.
Goodbye.
Bye bye.